This video is about the chi-square test for independence. You can use this test to see whether two variables or attributes are independent or not. To calculate the observed frequencies of the two variables, when you enter the two variables in the two-way classification table, what they call contingency table, we calculate the expected frequency of the ith row and jth column, and you denote it as E sub ij. Is going to be equal to the total row I times the total row j divided by the grand total. The number of degrees of freedom in this chi-square test will be the number of rows of the contingency table minus 1 multiplied by the number of columns minus 1. Let's apply this to the following problem. Suppose the results of a random sample of 300 children with pain from musculoskeletal injuries are treated with acetaminophen, ibuprofen, or codeine. And this is shown on the following table. The alpha equal to 0.1 significance. What is the expected frequency values? And can you say that there's enough evidence to conclude that the treatment and result are independent? Let's first define our null hypothesis. So null hypothesis will be that the treatment and response are independent. Our alternative hypothesis is just treatment and response are dependent. Since we have alpha equal to 0.1 significance, then our critical value is determined by chi alpha nu equal to chi 0.1 nu. Our number of degrees of freedom in this case, since there's 1, 2, 3 columns and 1, 2, 2 rows, then it's v minus 1 times 2 minus 1, which is 2. Okay, so there's 2 degrees of freedom here. So chi alpha nu is going to be, so 2 degrees of freedom, 0.1. Let's clean this up. 2 degrees of freedom, that's 0.1. It's right here, so the intersection looks like it's 4.605. 4.605. Now, to get these expected frequencies in greens, so remember the formula for the expected frequency is the total row I times total row j divided by grand total. Just do this for a couple of examples and then you can figure out how to do the rest. For example, this is E11. E11 is the total of row 1, which is 200, times total of column 1, which is 100. Oops, this total column J, column 1, so but the grand total is 300. So this is clearly just 2/3, 200 over 3, which is exactly 66.7. I'll just do one more example. For example, this one here. This is E second row, third column, E23, total of row 2, times total of column 3 divided by grand total, which is 100 divided by 3, which is 33.3. That's how we got this. Okay? So then we just need to calculate the chi-square test statistic. Remember, this here is the sum over double sum over all ij. Again, observed value minus expected value squared over ij. So then, calculating all this out. Right? So, for example, it's 53. It's 53. In fact, you get 14.07. And if you compare this value with this value, so the test statistic is greater than the chi alpha nu, which means that we are in the critical region, which means that we reject. It's not. Which means that the treatment and the response are exact dependent. Okay. So in fact, the drug you take for musculoskeletal injuries is better treated with respect to one of these painkillers. There's a dependence on how well the treatment is and the painkiller you take. Let's do one more example. The side effects of a new drug are being tested against a placebo. A simple random sample of 565 patients used the following results below. At a significance level of 0.05, is there enough evidence to conclude that treatment is independent of the side effect? So again, let's define our null hypothesis. Treatment response are again independent. Our third hypothesis is treatment and response are dependent. Our chi alpha nu for the critical region is going to be chi 0.05. Since there's only 2 rows and 2 columns, then just 2 minus 1 times 2 minus 1, which is 1. So at 1 degree of freedom and 0.05, we have this 3.841. Okay, let's highlight this for later. Now let's compute. Okay, so let's compute the expected values. For example, I'll just do this one. You highlight in green. Expected value here would be E11 is total of row 1 times total of row column 1 divided by grand total. Put that into calculator, is actually 25.15. Here E21 is going to be row 1 column 2 is going to be 49 times total row 2 275 divided by grand total 565. is in fact 23.85. And so on. You can do this here too. It's going to be 264.9. This one will be 231.2. And so basically now you just compute the chi-square statistic, test statistic. It's double sum, right? Observed minus expected squared. So I'll just give maybe write out all the calculations here. Well, 36 plus 13 minus 23.85 squared divided by 23.85. Oops, this is 20. This is 25. Oops, there's no square here. This is 25.215 plus 254 minus 264.9 squared. 264.9. 262 minus 251.2 squared. 251.2. In fact, the test statistic will be 10.53. And if we compare these two, then we can conclude that the chi-square test statistic is greater than the chi-square for the critical region. So therefore, we reject the null hypothesis, and treatment and response are dependent. Okay.